Hello, Alvin ISD mathematicians. Today we're going to be talking about shape, center, and spread of data, which is our 6th grade standard of 612B. So how are we going to be doing that? Well, we'll be describing those shapes, centers, and spreads of graphs by using measures of central tendency. Remember, in last lesson, we learned that central tendency are measures such as mean, mode, median, range, interquartile range, things like this that just describe what the graphs look like, and we'll use those to describe the shape, center, and spread. This is your learning target. So by the end of today's lesson, you should be able to answer this question if you've gotten the material. So I want you to take a moment, boys and girls, and I want you to pause the video and think about how these images are alike, or maybe even how they're different. And once you have a couple of ideas, please rejoin the video. All right, perfect. Thank you for joining. So one of the first things that I noticed is they both have peaks. So they both have peaks, and they actually have a couple different peaks. And then they also still have some valleys. Valleys right here. We have a valley right there. And then I even noticed that there's actually a cluster of mountains right there. And then down here I see that there's a big gap. So they kind of all have peaks, gaps, valleys, clusters of things. So keep that in mind as we move forward into the material. Our first way of describing graphs is describing their center. Describing their center means looking at their mean, which is the total of all the values divided by the number of values in the data set, or by looking at their median, which is the middle number of the data set. Center describes exactly what it sounds like it would. It describes roughly where the middle of a data set is. So in this case, our center would probably be 6. To describe where the middle point of all of that is. Spread describes how far things are spread apart. So the first thing that we look at with spread is our range, which is the difference between the minimum and the maximum of a data set, which in this case would be 9 and 4. So that range would be $5. So the amount of money spent on school lunches was spread from $4 to $9, or had a $5 spread. And then our second measure of spread is interquartile range. The interquartile range, again, if you remember from last week's lesson, is the difference between the third quartile and the first quartile of a data set. And remember, the first quartile is the median of our lower half of data, or our first half of data. And then the third quartile is the median of the upper half of the data, or the second half of our data. And again, spread, both of these values just help us kind of understand how far apart or close together all of our data points are. Lastly, we have the shape. The shape of a graph gives us a little bit of information about how something is distributed. So if we have a uniform distribution, notice every single one of the humans is the same height. So if I was looking at a bar graph with a uniform shape, every single bar would be at the same height because the values for all of them would be uniform. Symmetrical means that if I if I drew over it, it would have almost a line of symmetry. So if I'm looking at a dot plot, that'd be something that would look along the lines of this. So I can trace the top of my data, and it should be symmetrical. Now, skewed means there's more on one side or there's more on the other. It is not even. Notice our balance beam is tilted one way for our skewed. And we'll actually discuss on the next slide 2 different ways of describing skew. So when we have skew, it can be skewed left or skewed right. If you take a look at this first graph right here, notice it has a long tail on the left. What this tail means is there's a point out here which we call an outlier. And that outlier is actually pulling the shape of the graph to the left. And an outlier is a data point that doesn't really fit in with the rest of them. It's on the outside of something. So when we're skewed left, our outliers are on the left. So if I take a look at this stem and leaf plot, which I've rotated, I can draw over it. And notice my tail is on the left. And again, with my box plot, I have the longer tail right here. So then over here, if I'm skewed right, that means that my outlier is over here, and it's pulling that shape to the right. So for skewed right, our outliers are on the right. So that our tail is on the right, that is the direction of the skew. So if I have a graph that is not skewed, then generally we're not going to really have an outlier. All of our data points are very close together, and our mean and our median will match up. Notice, when we're skewed left, our mean and our mode and our median look very different than our mode, our median, and our mean. Our mean is on the left of the median if we're skewed left, because that outlier affects the mean and pulls it to the left of the median. And if we're skewed right, our mean is on the right of the median, because that outlier is pulling the average or pulling the mean farther away from the middle. So now we're going to go take some practice. We want to know what's the spread, oopsies, and that's a typo, and we want to know the center. So the first thing we'll do is look at spread. And for now, I'm just going to look at the range. So I'm going to order my numbers from least to greatest, just to help me with my thinking. So if I have my minimum value of 1 and my maximum value of 19, then my spread here will be 19 minus 1, so the range is 18. That means that this data set is spread out 18 values, or 18 kind of quantities. Now we want to know what's the shape, the center, and the spread of this box plot. Well, first we can look at the shape. I see that we have a tail to the left, that it's longer on the left. So my shape will actually be skewed left, which means that my outlier is on the left. So it's pulling my mean to the left. So the mean will be on the left of the median. Our center, which I can find right here with my median, is in between 5 and 6. So my median will be 5.5. And for spread, we can find our range and our interquartile range. For my range, my maximum was at a 7 and my minimum was at a 2.5. So my spread is actually 4.5 for range. And then my interquartile range, which is the range of my box, or the distance between my third quartile and my first quartile, is the difference between 6 and 4.5, which is 1.5. So now we have our dot plot. What is our shape? So I'm going to kind of go over my data. So I see that my tail is on the right here. So my shape is skewed right. And if I'm skewed right, that means that my outlier is on the right side of all the data, pulling that mean away from the median. My center, which I can use my median for, I can actually cross off points to find the middle. So I will start with the least and the greatest. So 15 and 50, so I crossed off 2. Then I'll cross off more as I go. Oops, bottom up. So I need to find the difference between 25, or the middle point between 25 and 30, which I get is 27.5. And then for my spread. And for now, I'm only going to identify my range. You could also identify your interquartile range from your dot plot by listing out all of your numbers and then calculating your quartile values. But for my range, the difference between 50 and 15 is 35. So my graph has a spread of 35 alligators. This takes us to our learning target. Mr. Miller shops for a new printer. He searches the local ads for printers and records the prices as shown. Which value best describes the spread? Boys and girls, please take a moment to pause the video and attempt this on your own. Whenever you have your answer and you're ready to check, please come back and join us. All right, thank you for joining us, boys and girls. So 150 was my maximum, and 79 was my minimum. Remember, spread is range or interquartile range. So our range for this is 81, because 81 was the difference between 150 and 79. Thank you so much for learning with us today.